Welcome to the video. Here in this video, I will be discussing about the rank of a matrix. In the previous video, we discussed about the Gauss elimination method. Okay, here we are dealing with the rank of a matrix. We can find the rank of a matrix by row reduced form or by method of Gauss elimination method. First of all, what is a rank of a matrix? A rank of a matrix is the largest order of any non-vanishing minor of the matrix. A rank of a matrix is the largest order of any non-vanishing minor of the matrix, which means if you are given a matrix 1, 2, 3, 4, this is a 2 by 2 matrix. We want to find the rank of this matrix. First of all, find the determinant. Here the determinant is equal to 4 minus 6, that is equal to minus 2, which is not equal to 0. Here this is the minor with non-vanishing value because here determinant is not equal to 0. Therefore, here the rank of this matrix is its order, that is 2. Similarly, if you are considering a matrix some 3, 2, 1, 0, 1, 1, 0, 0, 1. Finding this determinant, we have 3 into 1 minus 0 minus 2 into 0 minus 0 plus 1 into 0 minus 0, that is equal to 3. Here not equal to 0, therefore here also rank is equal to 3, order of the matrix. Suppose if this matrix determinant is equal to 0, suppose the determinant of this matrix is equal to 0, then we can find a minor from this matrix. Okay, here I can write the minor as 3, 2, 0, 1, matrix 3, 2, 0, 1, or the minor 2, 1, 1, 1, or the other possibilities are 1, 1, 0, 1, etc. If the minus determinant, the determinant of this matrix is not equal to 0, then we can say that the rank is equal to 2. First of all, we consider a 3 by 3 matrix. Suppose its determinant is equal to 0, then the rank will not be 3. At these cases, we considering the minor from this 3 by 3 matrix. If you are considering a minor 3, 2, 0, 1, then finding its determinant, if it is not equal to 0, then the rank of the matrix will be 2. So this is the definition for a rank of matrix. It is the largest order of any non-vanishing minor of the matrix. A matrix is said to be of rank R, then it has at least one non-zero minor of order R. If the matrix is of order R, then it has at least one non-zero minor of the order R. Okay, that is here. If the rank is 2, which means it has at least 2 non-zero minor of order 2. Okay, then the rank of the matrix is usually denoted by R of A or row of A. We are usually denote R of A for the rank of matrix A. Then this is not practically easy if you find the rank of larger order matrix. So at that cases, the rank of a matrix is the number of non-zero rows in that matrix. If you are given a 5 by 4, 4 by 5 matrix, this formal definition, it is not practically easy to find the rank of that matrix. So we usually use this formula, that is the rank of a matrix is the number of non-zero rows in that matrix after row reduced form. Okay, after row reduced form, check how many number of non-zero rows are there, then that number is taken as the rank of the matrix. Let's see the examples. Find the rank of the matrix 1, 2, 3, 1, 4, 2, 2, 6, 5. First of all, write the matrix 1, 2, 3, 1, 4, 2, 2, 6, 5. Next, I am going to reduce this matrix into its row reduced form. Okay, that is the upper triangular form. Here, the diagonal is 1, 4, 5. So, I want to make the elements 1, 2, 6 as 0. So, the first transformation is R2 changes to R2 minus R1. So, first row as same 1, 2, 3 and the third row as 2, 6, 5. Second row is R2 changes to R2 minus R1, that is 1 minus 1, which is equal to 0. The second element is 4. 4 minus 2, that is equal to 2. Then the third element is 2 minus 3, that is equal to minus 1. So the second row is 0, 2, minus 1. Next I want to make this 2 as 0. So the transformation is R2, R3 changes to R3 minus 2R1. Then the matrix become 1, 2, 3, 0, 2, minus 1 and R3 changes as 0, 2, minus 1. Next I want to make this 2 as 0. Then only it become a upper triangular matrix. For that the transformation is R3 changes to with corresponds to R2. So R3 changes to R3 minus R2. So the matrix become 1, 2, 3, 0, 2, minus 1 and the last row is 0, 0, 0. So here this is in the upper triangular form. Next find how many non-zero rows are there. Here the first row 1, 2, 3, all the numbers are non-zeros. Consider the second row 0, 2, minus 1. Here there are two numbers which are non-zero. Okay, so here this second row also a non-zero row. What about the third row? All elements are 0. So here there are only two non-zero rows. Therefore, this matrix rank is 2. Okay, can we find the determinant of that matrix? Okay, if you find the determinant of the given matrix in the question in the problem, its determinant will be 0. So we cannot take the rank of that matrix as 3. Okay, here there are only two non-zero rows. Therefore, the rank of this matrix is 2. Next problem. Reduce to echelon form and find the rank of the matrix A equal to 1, 2, minus 1, minus 2, minus 4, 2, 3, 6, minus 3. First of all, consider the matrix. Here, the diagonal elements are 1, minus 4, minus 3. So, we need to make minus 2, 3, 6 as zeros. So, the first transformation is R2 changes to, yeah, minus 2 is the element. So, R2 changes to with respect to R1. That is R2 minus, not minus. Here already the element is minus 2. So, plus 2R1. Similarly, R3 changes to R3 minus 3R1. Then we get the matrix 1, 2, minus 1. Second row as 0 and the third row as 0. So, here the number of non-zero rows is 1, which is the first row. Therefore, its rank is 1. Okay. Third problem. Reduce the matrix to row reduced form and hence find the rank of this matrix. The row reduced form is also known as echelon form, row echelon form or Gauss elimination method. Okay, these all are same method. This is the matrix. Here 2, 3, minus 1, minus 1 and the second row 1, minus 1, minus 2, minus 1. It is easier when we interchange the first two rows. Okay, so I am going to interchange R1 and R2. So the matrix will become 1, minus 1, minus 2, minus 1, 2, 3, minus 1, minus 1, 3 1 3 minus 2 6 3 0 minus 7. The first element is 1, so it is easy to make 2 3 6 as 0. It is R2 changes to, what are the transformations? R2 changes to R2 minus 2 R1, R3 changes to R3 minus 3 R1, and R4 changes to R4 minus 6 R1. Okay, these are the transformations. Then the corresponding matrix like this. Next, we want to make this minus 4 as 0, this 9 as 0, and 12 as 0. Consider the elements 4 and 9. With respect to R2, you want to make 4 and 9 as 0. So the transformations are R3 changes to R3 minus the corresponding element in R3, that is 4 divided by, with respect to R2, so corresponding element in R2 is 5. So 4 by 5 R2. Similarly, R4 changes to R4 minus 9 by 5 R2. Here there is a correction. This is R2. Then our matrix become 0 minus 1 minus 2 minus 1 0 5 3 1 as same. Then third row as 0 0 33 by 5 1 by 5 0 0 33 by 5 minus 14 by 5. This matrix is not in an upper triangular form, so we want to make this 33 by 5 as 0. The transformation is R4 changes to R4 with respect to R1, so R4 minus R3. Then we have 1 minus 1 minus 2 minus 1 0 5 3 1 0 0 33 by 5 1 by 5 0 0 0 minus 3. Here all the rows are non-zeros. Okay, in the first row all elements are non-zeros. Second element also we have 5 3 1 as non-zero elements. From the third row 33 by 5 1 by 5 are non-zero numbers, and from the fourth row minus 3 is the non-zero number. So here 4 non-zero rows are thus. Therefore this matrix rank is 4. Therefore the rank of A equal to 4. So this is method to find the rank of a given matrix which is of any order.